Hello, Valley Middle School STEM. This is Mr. Martin here, ready to ride along with you on another fast and furious STEM's Day adventure as we go to the Fast and the STEM wind-powered cars. Before I get started today, here's your trivia fact. So, did you know that the world's fastest wind-power car, it's called the Greenbird, and it went 126.1 miles per hour? And there's a picture of it on the right. It was record was set in the Australian outback desert. Doesn't look like it would be a great car for taking family vacations on. Not a lot of storage space, but still pretty awesome that it got that fast. As always, when we do these STEM's Day activities, we are doing this to practice through our collaborative design process. So during the next 2 days, you will go through each and every part of this wheel right here. And as always, we get started with the challenge. And here is your challenge for this activity. Working in a team of 3 people, you are going to design and modify a Hot Wheels car and get it to travel 10 feet, being only powered by a fan. That is it. You cannot push it, you cannot propel it in any way besides the fan that was provided to your advisory teacher. So here are the constraints. First of all, it must only be wind powered, so you may not take rubber bands and shoot it, you can't push it, you can't throw books at it or iPads at it, only powered by the fan. It needs to travel at least 10 feet. That is the goal you are aiming for. That is 10 segments of Hot Wheels track. Anything that goes farther is fantastic, but 10 is the target you are shooting for here. And you can only use the materials that have been provided to your group. Now, you do not have to use all of them. I've given you a variety of options to figure out a way to harness the wind. You will have straws, you will have plain printer paper, masking tape, toothpicks, coffee filters, and of course, one Hot Wheels car to modify. That is your challenge. As always, we want to just jump in and start building, but we have to slow ourselves down a little bit and first go through the imagine stage. So we're going to do some observing, wondering, brainstorming. So working with your group, spend some time talking about, discussing, how do you plan to modify your car that you selected? What are you going to do to harness the wind? What materials did I provide for you that may help? How are you going to attach it to the car? How are you going to make sure the car's weight is balanced so it doesn't just tip over when the wind starts pushing it? All things you will need to consider, and there's probably other considerations out there I haven't even thought about. After you are done brainstorming with your group, then we're going to go into the design phase. So now we're taking your best ideas that you brainstormed with your group, and you're going to sketch out what this is going to look like. You can use one of the sheet of paper that I have provided for you and then repurpose that later, or you can take any old scratch paper and draw out what your design looks like. Once you have a good sense of what your design is going to be, then you get to start building with our friend Bob here. And so in your group, you're going to modify your car, your Hot Wheels car, based on your design. Remember, the constraints I gave you can only be powered by the fan. You need to figure out a way to harness that wind power and try to get it to travel at least 10 feet. After you've done building it, you're going to have to test it out. So remember, it's not always going to go on the first try. It may take multiple tries. So you're going to test it, evaluate what worked, what didn't work. Go fix some things on your car, bring it back, try it again. And your goal is to try to get the farthest that you can get in your class. Teachers, we have a job for you. You're going to need to lay out all 10 track segments in a straight line somewhere in your classroom, probably near a wall, so you can plug in the fan. Place that fan about 8 inches behind, and you're going to probably want to tilt it downward a little bit so it's aimed towards the car. And students, you're going to then bring it up and test it, try it out, fix it, modify, try it again, and just keep going back and forth on these 2 steps. After some time, of testing and evaluating and fixing, you're going to, as a large group, then talk about a little bit what worked, what didn't work, what did you observe other groups that did really well and successful. Are there any other wonderings you have? What if we had a bigger fan? What if we had different materials? How could we make it work? Share some of those out as a class. And teachers, why don't you go ahead and submit a picture of me, to me, not of me, to me, of the car that travels the farthest in your class. And the advisory that has the farthest traveling car will, of course, win donuts for the advisory. All right. After all of that, of course, you're going to want to clean up your space, so be sure to do that. I have on the slideshow that I have sent to teachers, you can click here for a little help on the cleanup process. I highly recommend it. Here's what your suggested schedule would look like. It's going to be split out over 2 days. So on Wednesday, you're going to show this STEM Day video, which is running a little over 6 minutes at the moment. Spend some time designing and imagining, and maybe do a little building if you want. But I would probably save the building, testing, evaluating for Thursday, some time to share, and then, of course, some time to clean up. Good luck to all of you. And teachers, don't forget to send the pictures of the cars that traveled the farthest. And as always, please don't forget to like and subscribe. Good luck, everyone.